All right, good morning. So hopefully you have a good understanding of this idea of meiosis from yesterday and how that genetic variation is generated from that process. So the idea of crossing over in prophase 1, where you have alleles exchanging from one chromosome to another so that they're still on the same chromosome. For example, we have chromosome 2, chromosome number 1, so we could have alleles go from this chromosome 1 to this chromosome 1 during crossing over, and that creates genetic variation. And then the metaphase 1, where they're separating the homologous pairs, and that's random, which is that 8 million number, which is just mind-boggling. And then random fertilization, which gets you to 64 trillion combinations of children that can be created from two parents. Okay, so just craziness to me to always think about. So what we're going to do today, and really kind of for the rest of the time here, is to start looking at genetics. Today you're going to look at corn genetics, which is going to be monohybrid and dihybrid crosses. The knowledge probe is 14.1 and 14.2. These knowledge probes are going to, in the worksheets, if you choose to do worksheets, are not so much like fill in the blanks like they have been, but it's more practice problems. So you might decide to look at a couple of those versus just reading the book, because those worksheets are helpful in terms of like trying and doing genetics. But the corn genetics is going to walk you through both monohybrid and dihybrid crosses. So it's going to look like this. And you will do some chi-square analysis. So you guys could practice that a little bit. And then there is some reading in here. So I would probably just do this instead of like reading through the textbook for these knowledge probes. But that's kind of up to you. But this is an assignment. So you'll scroll through, read through this, become comfortable with the vocabulary because all of your questions are going to have that vocabulary in it, so it's important that you understand it. And then this first part looking at selective breeding is going to be the monohybrid process, where you're crossing purple corn with yellow corn and getting all the purple. And this is all actually the way that corn is inherited. So you'll go through some practice with heterozygous, homozygous, in using those terms. You'll do some counting. So you'll look at these 2 ears of corn, and what you're going to be able to do with this is predict what the parents are based on the ratios that you see of these crosses. So it's kind of interesting to be able to see the number of kernels that show these different traits and use that information to predict what the parents were. Okay, so for this first cross, you're just counting number of purple and number of yellow for corn. Make sure you're paying attention to which ear is which. This is B and this is A. It's just the way that it got scanned. So you look at that and do some counting, fill that in, get the ratios, answer some questions, do some data analysis. For the Punnett squares, these are drawings. So if you click on the drawing and then click edit, there are text boxes in here that you can just click on once it loads, and you can put your alleles on the outside. Those are the gametes that are produced from meiosis, so that's separating the genotypes. And then inside is where you would show fertilization happening. So this is what's happening after fertilization. So this might be the egg and this might be the sperm, and these are your possible combinations. Okay. So then when you click save and close, it'll just show up right on your document. So all the Punnett squares are like that. So you'll go through and do some practice. These are all what we would call monohybrid. Underneath, then you have dihybrids. Don't get confused. These should be R's, but we changed the P to the R, and so this is a diagram from the initial document. But what you're looking at is both 2 different traits. So now you're looking at color, and you're looking at the smoothness or the wrinkledness. It's really the starch. Okay, so starchy versus sweet. But the way to see that is whether they're wrinkled or smooth. All right. So with these dihybrid crosses, there is a video there. But essentially, remember, it's this idea of, what do you call it in math? Distribution. So remember that this R and this R are on homologous pairs. So the big R might be on this chromosome and the little r on this chromosome. So when you are creating your possible gametes, they can only have one big R or one little r, because these homologous pairs get separated during metaphase 1. And then the same thing with the S. So this would be, the R would be here and the S would be here, R, S, and then those are being separated, okay? So we're going to assume no crossing over. So when you're making these combinations, it'd be a capital R, capital S, capital R, little s, little r, big S, little r, little s. And then the same thing here because the both parents are heterozygous. But watch the video if you don't remember, if you get stuck, okay? And that kind of walks you through it. Then again, you're going to count. What you should find when you count is that it's a 9 to 3 to 3 to 1 ratio, and that's going to always be true when you have two heterozygous parents, all right? Answer the questions, go through, do some math about what is observed. So here you're going to do some counting again on corn ear C. And when you're counting, this one you do have to be careful because you're looking at whether they're smooth or wrinkled. So as you're that yellow line on the top, and then these are the wrinkled ones that are all shriveled. So these shrivelly ones that you can't even see are the wrinkled. These are the yellow. So this would be yellow smooth, this would be purple smooth, this would be a purple wrinkled, that looks like a purple wrinkled, that looks like a yellow wrinkled, okay? So you're going to count again. The first time you're just counting ear C, right? And the second time you're going to look at ear D. So you record your counting in here, and then do some work, answer some questions. Predicted ratio is going to be 9331. That's going to come from your Punnett square, so you can see that here. And that's where you're seeing these to get your observed number from what you counted, and then observed minus expected. Okay? So that then walks you through. Then you're going to do the same thing with ear D. You guys can work together on this. So like if you get hooked up with a partner and one of you comes C and one of you comes D, by all means share your numbers. Okay? There's no reason for you to count both C and D. And then finally, there's just some information about other types of breeding and the ways that agriculture is using this idea of genetics, okay, in terms of selective breeding, doing genetically modified and some of the biotechnology that we hear about with crops and stuff. So it'll take you a little bit of time. You should have enough time to finish it within those 2 hours of class time. You should have some extra time on top of it too. If you get stuck, let me know, and I can answer some questions. And you guys will have a great day, and I'll see you on Thursday.